what is statistical modeling? Statistical modeling is a formalization of relations. Actually, it is about finding out, extracting relations between variables in the data. And what is meant by a variable? For example, a variable is anything like attribute. Let's say you have a person. His attribute is like weight, height, etc. So these becomes the variables. When you take measures, when you take samples from the real world, attributes of different people form the variables. For example, height of different people in one particular state, and weight of people in one particular state. So when you want to try to analyze such kind of data, you want to especially get some information about what is the average height, what is the average weight. Why should I really care about average height? Can somebody give a business case? Why should I really care about height of people? Business case, I'm talking about real business case, something that gives you money. You know, the whole point of all the statistical modeling, all this is not to do research, right? At least from the industry perspective, since I believe most of you guys are from the working people sector. Otherwise, you wouldn't be here. You would be in some academics, right? So when customer comes to you, they are looking for monetization. When customer comes to you, they need to see money. They don't want to see your theory about how X is equal to Y, beta and alpha, gamma. They don't want that. All that they care for about is money. If you cannot express your statistics as a money making revenue generation profit, then your project will not succeed. So we receive many customer requests daily, and we have to express them in terms they can understand. What they can understand, one thing is money. So they need to see benefit. Otherwise, they won't come to you. They can go to alternate, companies. So let me ask you this question. There is a business case. Can somebody give me one business case which is important for me to understand the average height of people, or let's say median height of people, or whatever is some kind of summary, aggregated value about people, heights of people. Can somebody come up with a business case quickly? Most of you are already benefiting from that, actually, right? Because human beings have the tendency to stick to some kind of normalization. For example, most of the people who are in certain age, mostly, are at certain height. Exactly. Tricha is giving a very good example. For example, if a person is at age 30 or so, then based upon his waist, you can actually tailor his clothes. For example, when you go to a ready-made shop, you can find clothes that almost suit you, right? Almost suit you. Yeah, Puneet is giving an example. That's correct. Almost suit you. How did they come up with that? Based upon your waist, maybe 32 inches, 28 inches, 30 inches, based upon that, they are able to give you exact, something that, of course, you may need to make certain customization a little bit here and there, because you may have to trim the ends of the pants, etc. But then everything else suits perfectly, right? Your hip and your length, everything else suits perfectly. How did they come up with that? They come up with that because of the statistical modeling. They analyzed hundreds of people, and they came up with a relation saying that the length of a person, the length of his legs is related to his waist, hip, and certain features. And then they made ready-made inventory, so that you don't need to spend 2 or 3 days just to buy your appropriate clothes. You can just go there, pick up the cloth, and trim it at the ends, and then you are ready to go. So that is one of the real business cases. So this is the kind of thing the customer want to listen to you. For example, they say, we have this kind of data. What can we do there? Because mostly customers have data right now in the industry today. Everybody has their own data, but they don't know what to do with the data, right? So that is where you have to give them ideas, saying that, hey, if you do this, you can do that. You can gain 30% increment in revenue, etc. Right? That is all statistical modeling is all about. So, and for example, I think, yeah, here itself it says, right? For example, height equal to beta expressed as a variation of age and something. The equation may not be correct, but you get the idea. And then one of the basics of statistical modeling is like regression modeling. What is called as regression modeling? Very basic scenario, very basic, simple, straightforward. I believe you guys already know it, and you already did it, maybe in a different term, maybe under a different heading. For example, fitting a line y equal to mx plus c. So everybody knows that y equal to mx plus c. The value of y is dependent upon slope and intercept. Right? That is one form of regression modeling, one of the basics. So regression modeling is all about, regression means trying to find out relation between two kinds of variables. For example, I give you x and I give you y. So there is a dependent variable and independent variable. What it means is, for example, time. Time is independent of anything. Time keeps ticking. It doesn't depend upon anything. But sales, for example, they may depend upon many factors. Or let's say the velocity, they may depend upon many factors. The thrust you are putting on the pedal, and the inclination, the slope, etc. So there are certain independent factors, there are dependent factors. So your whole goal is, fundamental goal is to find out the relation between them. And one of the simplest forms is regression modeling, where you come up with linear equations or certain equations. For example, like linear regression, where y equal to mx plus c. And then there are logistic regression, where the equations are not directly expressed in their plain terms, but you take logarithm and you express them. For example, like this, log e, etc. So we are going to see some of these in practice actually. So, but here I am trying to cover this as a, mostly as a reminder for those who already know, and just as an introduction for those who don't know. Okay, Sanjeev is saying logistic regression. Okay, logistic regression is same as regression, saying that okay, I have two variables, right, x and y, but then I do not want to directly relate them, x and y, as it is. What I want to do is, why is that? For example, what happens is, let's say take exponential growth. Exponential growth is like, for example, let's say population. Population in one certain country may be growing exponentially. Exponentially means today it is at 1, tomorrow 2, next day 4, 8, 16. This is exponential growth. It's not linear, right? But then time ticks in linear. For example, today 1, second day. So this is third day, fourth day, fifth day. So this is linear, right? Time is linear. Time is linear, whereas I'm just giving an example, right? So whereas this one is population is non-linear. This is exponential. So how do I relate these two? One way is you can directly take it as a, you can directly try to take a map between these two. But then the problem is the scale is different. One axis is going on at one rate, and the other axis is going on at a different rate. So what you typically do is you take a logarithm of this, so that the exponentiality is reduced to linearity. So when you take logarithm of these 1, 2, 4, 6, 4, 8, 16, that will be linear. That will become values like, for example, maybe I should take an Excel. Okay. So log of p, that is log of popularity will be, population will be, so actually this is 0, and this is 1, and this is 2, and this is 3, that is 4. So that is the whole point of exponentiality, logarithm. So this is the case when you have this kind of exponential. So if you look at it, the difference between 1 and 2 is small, whereas the difference between 8 and 6 is huge, right? That is an indicator saying that, so in a logarithmic axis, you typically see as the distance grows, the consecutive numbers will be too far. As you increase in the axis, the consecutive numbers will be too far. So that will bias your model. If you directly take the numbers, they will give you biased values, because these numbers are, remember, these numbers are relative numbers. What does it mean to say 8? What does it mean to say 16? When you say 8, you are saying from 0, it is at a distance of 8. right? When you say 16, from 0, it is at a distance of 16. So, but when, in a case where this distance is skewed because of this exponentiality, you will not be able to get straightforward. So that's why you take logarithmic. So now you remove this 1, 2, 4, 8, 16, but you straightly try to map logarithmic with the time. So that is just a logarithmic regression. Make any sense, Sanjeev? That is mostly just to try to scale it down. In fact, the scaling is very important phenomenon. We are going to see it more. I am going to cover that later. So how does it look like, visually? So this is what it is going to look like. For example, a regression modeling, when you look at it, it is going to, all you are going to do is you are trying to, for example, you let us say all these blue dots are your samples, what does they indicate? Each sample indicates two attributes, one attribute on the x-axis, one attribute on the y-axis. And you are going to fit, when you say regression, you are going to fit is a line, especially your kind of line. For example, one point here to be noted here is that when you are going to fit, it's not exactly a sloped line, it could be a curve actually on a multidimensional scenario. But for simplicity in a two-dimensional scenario, it is just a line. But then if you look at it, there are many points that are not lying on that line, right? Many points that are not lying on that line. But then you are trying to approximate all those points with a single line. That introduces two concepts. One is some of the points are on the line, which is given by the equation of the model. So this particular line has some equation, right? Y equal to mx plus c, whatever is that. M could be different, c could be different for whatever the values. It is a line, and some points, some of the blue points lie on that line, which means that those are valid points. But then there are certain points which give some error. So for example, take this point. Take this point. It is at a certain distance from this line. That means you are saying your data, all these blue points are exhibiting a linear model such as this line, whereas in reality they are not exhibiting that model. They have certain error there. For example, this point has some error, this point has some error. So that is the distance between your actual value and the predicted value, right? Distance between your actual value and predicted value. The whole goal of modeling, whether it is regression modeling, logistical modeling, whatever it is, the whole goal of modeling is to try to minimize this error, to try to minimize this distance. And why is something called as something? Sanjeev is asking why is it called elastic. Let's not go into that. Okay, let's stick to they call it as that. Let's take it that. Okay, maybe because it uses logarithm, maybe not. So let's not go into that. Okay. So the whole point, whatever it is called as, irrespective of what it is named as, what is it called, the whole goal is to reduce the distance between your predicted value, which is your black line here, versus your actual values there, right? That is the whole goal of the whole modeling. And to facilitate that, you need multiple tools. For example, how do you measure the difference between your actual values and predicted values? How do you measure what is error? So that is called as error, right? So residual, also called as residual, R-E-S-I-D-U-A-L, residual. So the whole the point is how do you find out what is the difference between your predicted value, which is this black line, and what are the actual points there. So what is the error? How do I minimize the error? So in this case, is regression modeling, is the linear modeling, first of all, is the linear modeling is the right model or not? What are the alternate models? So these are some of the questions that are answered by statistical modeling, right? So what are some of the techniques, other techniques there? What are some of the other techniques? For example, let us say let us take a bigger picture. So a very wide picture. Let's not go into individual models because individual models have their own drawbacks and everything. Let's start from a basic. Let's start from what is the whole scenario on a large scale. For example, take this. The whole of analytics, if you try to summarize it, it boils down to these kind of models. So, right, it could be logistic regression. Let's not go into the names, right? Let's not go into one particular because each tool has its own drawbacks, and we are going to cover some of these techniques. But at the base level, when you say analytics, especially business analytics, you are talking about one of these kind of three models. One is a predictive model, where you are really interested in finding out what happens in the future. What happens in the future? For example, whether customer is going to default the loan. Default means not paying. Whether the customer is going to pay whether the customer is going to default the credit or not, whether the system is going to crash or not, whether a vehicle is going to break down or not. These are some of the predictive models, right? Very, very important in the right now, in this moment, in the real world, right now at this moment, this is what is gaining more and more popularity in the industry today. More and more jobs are looking for this kind of expertise. Okay. Descriptive models and decision models have been there. They have been there for many years. Statistics is not new thing. It has been there almost for many years. And descriptive models and decision models. Descriptive models essentially are about finding out the characteristic of the data. For example, what is the average income for my country? What is the GDP? What is the average life value, life expectancy for my country or for any country, right? So this is all about trying to understand the data and describe it in numerical ways, for example, mathematical ways, or coming up with some relations, right? In descriptive modeling, there is no challenge at all. There is no problem at all. This is also called as something like exploratory. You can understand it as an exploratory analysis, where customer gives you some data, or you get some data from customer. Customer doesn't have any problem at all, any challenge at all. But then you try to analyze the problem and try to come up with certain scenarios, and then try to explain to the customer, saying that, hey, your system, your data is behaving so and so way, and then use what is called a decision modeling. For example, the next one, decision modeling, where after understanding the data with the descriptive modeling, you try to come up with some certain optimizations, saying that, hey, vehicle vendor, let's say your government transportation, or your railways, or a large fleet owner, they are running some certain buses and trucks and vehicles, right? You understand that their business using the descriptive modeling, and then you come up with certain decision modeling which explains that, okay, hey customer, look at it this way. You are using your buses and trucks and vehicles this way, but you can save so much amount of money on driver schedules, on petrol, on vehicle uses, on improved assets, if you do this. So that is what decision modeling is all about. If you make so and so decision to not use this particular road, but instead use this road, maybe shortest road, then you can save so much amount of money. So that is what decision modeling is. Decision modeling has a target, which is nothing but optimizing. It does not worry about future. It does not worry about past. All it cares about is how do you optimize resources. For example, network planning, simulation, stochastic modeling, etc. Whereas predictive modeling is all about, it has a goal. And yeah, Puneet is giving some good example. Electricity demand forecast, right? Yeah, that's a good example. So these are some of the ways. And in fact, you can try to organize your thought processes, you try to organize your work, you try to organize your, even learning behavior based upon this. What does exactly customer want? Whether he is looking for prediction or whether he is looking for optimization. They can only want these two. Because descriptive modeling is customer doesn't want anything. You go and you take data and you try to analyze it. Right? That is descriptive modeling.